definition of logarithm so I can kind of get us going on this just a little bit. Okay, so to begin with, we'll look at what a one-to-one function. Pay attention, guys. I'm not done, okay? I'll be done in 10 minutes, okay? I know you want to go, okay? I'd like to go too, but I give you your money's worth in this class. I really do. I want to teach every minute I've got available, okay? That's just the way it is, okay? All right, so what a one-to-one function is it just means that each value in the range gives you one value in the domain. And mainly the reason I want to talk about this is just because we need to talk a little bit about an inverse. So let me explain what I mean by this. It's not that hard. What it is a function would be, a one-to-one function would have to look like this. Everything in this part, the range, has to have one thing that it corresponds to here. So the 9 corresponds to 2, 6 to 4, 5 to 11. That's what one-to-one functions look like, is like that. This one is not one-to-one, although the 9 corresponds to one thing, a 2, the 5 corresponds to 2 things, so it's not one-to-one, okay? So if you look at this example right here.
Is this different from the first time?
Now, what we did before is we did function, which was more this way.
Okay.
What we did before is we looked at a function this way. A function would be everything here corresponds to one thing there.
Right.
Everything there corresponds to one. See, this is a function.
Oh.
It's just not a one-to-one function. When you look at a one-to-one function, you look at it backwards, kind of. Okay?
So that could be a function now.
Yeah, that's a
But
function.
before it couldn't be a function.
Yeah, that's a function. No. This is a function, but it's not one-to-one. Okay? Remember, a function means everything here, one thing here.
Right.
Everything there, one thing there. That's cool. But if we do it backwards, it fails. So it's still a function, but it's not one-to-one.
So when you're dealing with logarithms, this is the rule, right?
Yeah, when you deal with logarithms, you got to deal with one-to-one function. Okay, so here's what you do as a student, okay? All right, first of all, this is a function. Everything there goes to one thing there, right? Now we look at one-to-one. One-to-one's backwards. The 4 goes to one thing, that's cool. The 5 goes to one thing, that's cool. 6 goes to one thing, that's cool. That is one-to-one, okay? Look at this one. First of all, is it a function?
Yes.
Okay? A goes to 2, B goes to 2, that's cool. C goes to 4, D goes to 3, that's cool. How about backwards? No, the 2 goes 2 places, so that's not one-to-one. Just think of one-to-one kind of like this. It's just like you have the same number of elements, okay? And it's like one thing, both directions. Both directions is how that works out, okay? So what we have with this then is it would work like this. This would be a one-to-one function. This would not be a one-to-one function. It's mainly because of that 2. That's what's messing you up on that, okay? And we're not going to talk too much about that. We're going to mainly kind of develop the idea of what a logarithm function is here and what the idea of an inverse is. So an inverse basically is just when you switch the variables. So for instance, if you had a point like 2, 6, then the inverse function would go like this. Then the point would become 6, 2. So an inverse is just when the points get flip-flopped backwards. That's the idea. We're not going to get real theoretical in this level of a class by that. We're just going to get enough of an idea to see what a logarithm is. And that's the basic thing that I want to kind of get you at least started on here today is how logarithms work. Now, I'm not going to worry too much about the graphing in this level of a class. So I'm not going to really go too much in depth over that. I want to kind of get you started with the definition of a logarithm and at least kind of get you to maybe doing this today. If I can get us through this, I think I'll feel pretty good. All right, so what a logarithm is it's the inverse of an exponential function. So one of the things you've got to learn how to do is how to interchange these things back and forth from one form to the other. Don't worry about all this terminology yet. We'll get into that next week. I want you to go to the next page and just kind of get you straight on one thing. I'm not going to get into the theory probably too much until a little bit next week. Okay, so what a logarithm is a logarithm is an exponent. It's another way of writing an exponent. So this is what I want to kind of show you how to do. You have a log form that goes like this. So you have like logarithm base b of some number x equals something like p like that. That's called the log form. The exponential form is like this. You say b to the p power equals x. So what I want to kind of get you through here today is just see if we can get this part straightened out and only this. Because all logarithms revolve around this idea. Okay, this is what we call a log form. It has a logarithm in it. The answer to a logarithm is an exponent. So what we're going to do is change this to the exponential form. So here's how you do this. That little subscript is the base. Okay, like I said, the answer to a logarithm is an exponent. So that's the exponent right there. So what you would have is you would have 2 to the 4th power equals 16. Is that right, by the way? Is 2 to the 4th 16? Yeah, okay. I tried to make these problems so that they work out that way. So a logarithm is a way to rewrite an exponent in a different way. You have to use logarithms when you work with financial formulas. That's why we teach it at a limited level in this class. Okay, this one goes this way. Okay, that's the base. That's the exponent. So you would end up with 7 to the 0 equals 1. Is that right? Yeah, okay. All right. What's the answer to the next one? Once you catch on, there's nothing to it. 9 to the 3 halves equals 27. I'm not going to worry about so much why that is, but if you put that in your calculator, 9 raised to the 3 halves, you get 27. So you want to be able to take a log form and write it in this form, okay? Now I want to show this to you backwards. Okay, so it goes like this. This is the exponential form, so it goes like this. Okay, first of all, always remember the answer to a logarithm is an exponent. So that 2 goes there. The 3 is the subscript, so that goes there, and then the 9 goes there like that. All you're trying to do, at least at this stage, is learn how to rearrange the numbers in the right order, okay? All right, next one goes like this. Okay, the answer to a logarithm is the exponent. If you remember that, it's pretty easy to put this together. Okay, the base 4 is the subscript, then the 8 is left over like that then. Okay, all right, and then this last one will go like this. Okay, we're going to just start it off this way. We would say, oh, that's a bad problem. I've got a logarithm in there. Scratch that out and let's make that something like 2 to the 5th equals 32, okay? No, that's not the point. The point is to take an exponential and change it to a logarithm. I already gave you a logarithm on that. That's in the wrong place. All right, so let me see if you kind of got this. What's the answer to this? What goes on the right side? 5. 5, 5, 5. I changed the problem. I changed the problem, okay? What's the subscript of the logarithm? 2, and then the 32 goes there, okay? So we'll get into this stuff a whole bunch next week after we're done with our test. So the idea is, when you have a log, this just means 2 to the 5th power is 32. This problem means 4 to the 3 halves is 8. That means 3 to the 2nd is 9. Now, all logarithms are based on that idea, so we'll work with that a little bit next week.
So we don't have no homework?
Get ready for your, well, you got my math lab, but you also got get ready for your test.